Hey, 7-1, we're doing angles of polygons today. Chapter 7 deals with all kinds of polygon stuff. All right? Tell your neighbor what a polygon is. Okay, poly means what? Many. Okay? When you're dealing with many, you have many angles here. All right? So, when you have a shape with multiple angles, we call it polygons. Now, you guys are familiar with a couple of the polygon names. First one, before we get into this theorem, if it has 3 sides. Good. If it has 4 sides. Not a square. Quadrilateral. If it has 5 sides. Pentagon. Just a quick review. Has 6 sides. Hexagon. What did Snow White say when the curse was lifted? Hexagon. Hexagon.
Oh.
All right. 7. Yeah, it's actually called a hepta or a septagon. Heptagon or septagon, depending on if you're dealing with Latin or Greek there. Okay. 8. Octa. What's the most famous octagon? Stop sign. 9. Nonagon. 10. Decagon. And then we'll actually do 12 as well. I'll write it over here. We're not going to do 11, but 12 is dodecagon. Dodecagon. I quite honestly cannot remember 11. I always have to look it up. Okay?
You should look it up.
Yeah, you should. Okay, theorem 7.1. Polygon interior angles theorem. I want you to read that and go ahead and tell your neighbor what it means. And do not just recite it. All right. Hey, now that you've talked about it a bit, can you explain why? Why does the sum of the measures of the interior angles of a convex, what's convex? Polygon is closed shape. All angles are pointing outward. Okay? I like to think of it this way. There's 2 different things. There's convex, and if it's not convex, it's concave. And the way I like to think about it is concave is like if I'm stranded on an island somewhere, I'm looking for shelter. I'm kind of looking for a cave. Okay? I could go, I know it's Pac-Man, okay? I can go camp like right in here. Now it'd be tough because I'm quite at an angle there, but it's a cave, right? There we've got a little cave. It's been dented in. Someone got mad at the shape and kicked it, and now it's dented. It's a concave polygon. It's caved in. The other way, like the technical math way, they'll say, hey, if a diagonal lies outside of the polygon, then it is concave. Well, a diagonal means, like, if I'm drawing diagonals for this shape right here, is 1 to 2 a diagonal? Okay, let's go back. Is 1 to 2 a diagonal? Okay, let's pause again. Is 1 to 2 a diagonal, yes or no? How many say yes? How many say no? Okay, it is no. What is 1 to 2 called? It is a line segment, but of a shape, what do we call that? That is a side. That is not a diagonal. Okay, is 1 to 3 a diagonal? Yes. Why? Because it connects 2 vertices and is not a... It is a line. It's not a side. Okay, is 1 to 4 a diagonal? Yes. Is 1 to 5? Yes. Okay? Now, is 1 to 6? No. How about here to here? Is that a diagonal? Yes. It lies outside of that shape. It is not a side and it connects 2 vertices. That is the technical definition of a concave. If you can draw a diagonal that lies outside of the shape, it is a concave figure. Okay, I like to think of it as someone got mad and kicked it, and now it's dented. All right. Or you can camp under the K. All right, how many triangles were made when we drew our diagonals? 1, 2, 3. Number of triangles, stay with me, that's 4. How many angles per triangle? Or excuse me, how many degrees per triangle? How many? Using all that information I just tried to give you huge hints on, explain why this formula right here works. All right, what do we got?
I got you.
Ooh, okay, hold on. Nope, we didn't have enough people here, so let's go with a different shape. Let's take a pentagon. Notice when I draw my shapes, I try to put dots first, which we end up having those as vertices as long as I can draw straight lines. Okay, we have pentagon. And N here is what? N stands for the number of sides and angles is 5. Okay, number of triangles? 3. Let me write this formula again for everyone. N minus 2 times 180 degrees. How many degrees per triangle? Any ideas on why it works? Isaac? You guys catch that? Yes. Sum of the interior angles, if we take N and we subtract 2, we always get how many triangles can be formed by drawing diagonals from a common vertice. And then if we multiply by 180, we have 180 degrees per triangle. Notice all those triangles, when we put them up together, they take all those interior angles. So it's easier to see in this shape. If I say this triangle right here, I have that angle, and that angle. So I have that whole angle. I have a part of that one, but notice the second triangle takes up another part of that one. It takes up the rest of this one. So now I have this angle, both of those, and part of that one. And then the third triangle finishes off that angle, takes up that one and that one. So you cover all your interior angles by those 3 triangles. And there's always N minus 2 triangles. That's what Carla was going to say. Oh, if only I called them. All right. Very good. That's what we got, man. N minus 2 times 180. We love that. That tells us the sum of the measure of the angles. Okay. Any questions? Okay. There's a corollary to it. The sum of the measures of the interior angles of a quadrilateral is 360. Most of you already knew that. All the angles of a quadrilateral add up to 360. Tell your neighbor what the exterior angles of a quadrilateral or of a polygon add up to. Those of you wondering what I mean by exterior, I mean this. That angle, that angle, that angle, that angle, and that angle. What do all those add up to? Alexis, what do you think? It does add up to 360. Look at their picture. It's not quite as cool as mine, but okay. All of them add up to 360. Okay. Hey, any questions? All right. With that being said, I want you guys to do that problem together. Right out your textbook number 4. Okay, I keep getting the same question. How do you know if something's regular? If its polygon's regular? Yes. Yes, regular means it is equilateral. And equiangular. what does that mean? That means all sides congruent and all angles congruent or equal. I guess more specific, we would want to say equal, not necessarily congruent. Okay? So, is it regular? No. How come? Yeah. Go ahead, Alex.
Oh, because there's three 90-degree angles, and if it's not congruent, those two, because they're not 90 degrees, it just says they're an angle and they're not congruent. So.
Good. All angles are not congruent, so it's not regular. No. Okay, measure of C and E, you say 72?
I don't know. I don't think that's right. It's not.
Hunter? How come? Okay, so you did 5 minus 2 times 180, which gives you 540. All right, N is, there's 5 sides. Okay. Why 270? Okay, so 3 times 90 is 270. Okay, and you got 270? Good, and you have those two congruent angles. You divide it in half. That gives you 135 each. Nice work. Good. So measure of angle E and measure of angle C are 135. All right. Yeah, any questions there? No. Okay, once you guys try number 6, or example 6 there. Give it a go. Hey, once we find out what n minus 2 times 180 is, what are we going to have to do? Divide by the total sides, which is n. So if you want to find out what one angle is in a regular, this is regular, meaning all the angles are equal inside, you're going to have to go, in this case, 12 minus 2 times 180 divided by 12, or 10 times 180. Which is 150. Very good. How do you find the exterior angle? Yeah?
I don't know. Can you just subtract 150 from 180?
Can we come back to that?
Yeah.
Okay. How do you find the exterior angle? How many degrees are outside? 360. How many angles are there? 12, and they're all congruent, right? It's 360 divided by 12. Now about 30. Okay? If that's 30, what's the interior going to be? Notice if I draw an exterior angle here, an exterior angle is 30 degrees. An exterior and an interior make a 180, make a straight line. If I zoom in here, a quicker way to do this might be to just find the exterior angle. Okay, 360 divided by 12 gives me that. That means the remaining angle right here is 150, because 30 and 150 make 180, just like we found. Is that what you're saying, Carla?
Yeah.
Yeah, I agree. That's faster. Lexus. Yeah? So on this one right here? On the previous example, we're dealing with an interior. Is that, so it doesn't add up to 360. Yeah, it adds up to 540 on that. 540. Yeah. Okay. All right. Any questions? Okay, page 199 is what you're working on right now. I want you to work down the columns, please. So I want you to do column 1 first. That's 1, 4, 7, 9. Then column 2 would be 2 and 15, or 2 and 5, and then column 3 are these down here. Okay, work down the columns. Start with 1, 4, 7, and 9. Okay, we're going to see how you did on number 1. Number 1 is 1,080. What does that mean? It means the sum of the interior angles is 1,080. That's a lot, dude. The sum of every angle, when you add them all up, right? Dude, that's a lot. All right? Okay, should be working on number 4. You haven't done so already. 9. Number 9, there it is. N minus 2 times 180. Plug in that 900 in there for the sum. Solve for n. You're kind of working backwards there. You get n equals 7. And then number 7 is 155 degrees. Okay, the total is 360. You have 205 taken into account. Subtract that out. At 205 out, you get 155. And the last one is 140 degrees. Please note that the two x sides are the same. All right. Hey, just really quick. What is a 15 gone? 24 gone? Yeah, so that's 24-sided. If we don't have a special name for it, which I'm sure there is somewhere, we call it we classify it by how many sides there are. So 15 gone means 15 sides. Okay, if you want to finish that up, I will put up the answers. You can kind of check them out and work on them. Okay, see how you did. That bottom one down there says 20. X equals 20. No, it's not very clear. All right.